Okay, I wanted to do an example from the homework of a word problem involving elliptical conic sections. So in this particular case, we're told that an elliptical ceiling of a building is 66 feet long and 25 feet tall. Someone discovered that they could hear the colleagues' conversations in the entire room if they stood at the focus, and they give us one of the points of the foci at C, the distance from your center to your foci, 0. How far along the major axis should he stand in order to overhear this conversation? So to begin with, anytime you're doing a word problem, you should take a look at what they're asking you. They're talking about an elliptical ceiling, so an elliptical cross-section, and they've given you some information that we can use to make a model. So I could go ahead and draw a little picture, a nice XY axis, rectangular coordinate system, and I would note that an ellipse could either be horizontally inclined, so a longer horizontal major axis, or it could be vertically inclined, a longer vertical major axis. So in order to figure out which it is, we take a look at what they've told us. They've told us that the ceiling of the building, the elliptical ceiling of the building, is 66 feet long. So if I were to place the ceiling endpoints here and here, let's say, it's not perfectly uniform in my picture, let me make it a little bit better. Maybe there's better. Okay, so if we have an elliptical ceiling, the total length of that ceiling, we're told, is 66 feet long. So if I were to go a total of 66 feet long, how many would that be on each side if I make 0, 0 the middle? That would be 33, correct? So this would be the point 33, comma 0, and this would be the point negative 33, comma 0. That's from the idea that it's 66 feet long. But because it's also giving us the height of the ceiling, it says it's 25 feet tall, 25 feet tall, from the center here at 0, 0, we could go 25. Now that's a little smaller than 33, so notice again, that's the entire length, whereas here, 66 feet long, we went completely 33 in each direction for a total of 66. Now its entire height from the ground up is 25 feet, so we're going to go 0 up to 25. And that would be at the point 0, comma 25. So that would make sense to describe the situation. And technically, if you were to have the entire ellipse, so if you didn't have a ceiling situation, but if you also had, like the floor was also elliptical shaped, then it would continue with 25 feet below here. But that's not the case. We're only talking about the ceiling. So in this situation, our sketch of our elliptical ceiling, if you will, is really a semi-ellipse that we're dealing with. We're dealing with this semi-ellipse. And we're given information about the vertices on the major axis, and we're also given information about an endpoint on the minor axis. So once we've identified the picture here, we could then create a model. So let's talk about our model here. Our model would need to be an ellipse. Again, it's a semi-ellipse here, but the equation remains the same. You're just looking at the top half. For the model, we would start off with the equation of an ellipse, which has a longer horizontal side, it seems, because it's 66 here, whereas here it's 50 if you were to do both sides here. So if it's a longer horizontal side, we would say it has a horizontal major axis, which would mean, if you remember the formula, x minus h squared over your a squared plus y minus k squared over your b squared equals 1. That would be the standard form for an ellipse with a longer horizontal axis than vertical. So a here is going to be our bigger number. A is the distance from the center, which in this case, the center we drew it at 0, 0. So here is your center at 0, 0. So with that in mind, in putting 0 and 0 here, wouldn't we just have x minus 0, or x squared, over whatever a squared is, plus y minus 0, which is just y squared, equaling 1? Thus, our model would become, noting that a is the distance from the center to the vertices on the major axis, what is a in this case? That's right, a must be 33. So a is 33, and thus we can square a, and if I square a times a, I get 1089. Okay, so I get 1089. So that means in my model here, a squared gets replaced with 1089. Now y squared is going to be over b squared, where b is the length of the distance, rather, from the center to one of the endpoints on the minor axis. So this is b units long. It would technically be another b units long if you had a full ellipse. It would be 25 then, wouldn't it? So b is 25, the smaller number in the equation of the ellipse denominators. And if you square 25, b squared would equal 25 times 25, or 625. So once you know that b squared is 625, we can replace the denominator of the y squared part and make it 625. So now we've created our model. It's a little ugly, let's fix that. We've created our model here. Still not beautiful, but you get the idea. X squared over 1089 plus y squared over 625 equaling 1. That is our elliptical model, and technically if you were to solve for y, you would just take the positive version for the top half. The negative version would give you the bottom half. Okay, so now we have the equation for the full ellipse, and we're simply asked to find where should this person stand. Should they stand here? Should they stand here? Where should they stand? They said let's go C units, left or right. In this case, C is positive, so we'll go to the right, and that's where we want to stand. But what was the relationship when we have an ellipse between A, B, and C? Remember that if you have an ellipse, the relationship was C squared equaled A squared, and it's always counterintuitive of your model, right? If that was a plus, you're going to put a minus here, whereas if it was a hyperbola, this would be a minus in the model, and this would be a plus. So it's minus B squared. So if I input my A squared and then subtract my B squared from it, A squared was 1089, and B squared was 625. And when I make that subtraction, what do I get? That's right, 464. So that is what C squared equals, which means then that C is the square root of 464, which if you go to your calculator is roughly 21.5. But if they say to round to the nearest whole number, you would just say roughly 22 feet. So what does that mean? We would need to go 22 feet to the right, so that'd be right here, 22 feet to the right, and that's where we would stand in order to hear the conversation of someone over here, because it's bouncing off of the ceiling and back down. So if they stand there and we stand here, we can overhear their conversation. So the answer here would be 22 feet from the center on the major axis. That's where we would need to stand, 22 feet away from the center. All right, I hope this video was helpful, and remember to practice because math is not a spectator sport, and I'll see you next time.